Welcome all. In continuation to our lectures on the GATE questions for 2023, today I have come up with some good questions on strength of materials. So I have tried my level best to include all varieties. So I'll try my level best to cover around 34 questions in strength of materials. So this is the first lecture of that series. So let us start doing beautiful questions. Okay, this is our first question. Now, have a look at this. A strain gauge is mounted. See, my sincere request is you may not get same questions, but concepts related to this may appear. So that's why let us try to digest concepts rather than just focusing on numerical values. Chalo. A strain gauge is mounted on the outer surface of a thin cylindrical pressure vessel. I repeat, cylindrical pressure vessel in the circumferential direction. Note down carefully. It is a thin cylindrical vessel in the circumferential direction. The mean diameter and thickness of cylinder are 4 meter and 20 mm. So the diameter is given as 4 meter. That I can write it as 4000 mm. Okay, that I can write it as 4000 mm, and the thickness is given as 20 mm. No problem at all. Okay, the Young's modulus is given. The Young's modulus and Poisson's ratio are given. The Young's modulus is 200 gigapascal. So can I write 200 gigapascal as 200 into 10 power 3 megapascal? Yes, because giga is 10 power 3 megapascal. So megapascal is also Newton per mm square. And the Poisson's ratio is also given. How much is that given? It is 0.25. Okay, no. Find the pressure inside the cylindrical vessel. He is asking what is the pressure. And the strain gauge indicates a strain of how much strain it is indicating. But note down that it is in the circumferential direction. It is inserted in the circumferential direction. So that is given by 7 into 10 power minus 4. This is the question. The diameter is 4000 mm. So I have converted from meter to mm, and the thickness is 20 mm. The Young's modulus is given, Poisson's ratio is given, and the circumferential strain is given. So let's try to solve this. We have studied in thin cylindrical pressure vessels. Whenever a thin cylindrical pressure vessel is subjected to internal pressure, it is subjected to the circumferential stress and longitudinal stress. And I have also derived in my regular plus classes beautifully with the help of models that the circumferential or the hoop stress is given by PD by 2T, and the longitudinal is given by PD by 4T. So this can also be written as a sigma 1 by 2. This can also be written as sigma 1 by 2. Now, let us take 1 as circumferential direction and let us take 2 as longitudinal direction. Very good. You know, my dear students, we have studied beautifully. The circumferential strain is given by sigma 1 by E minus nu sigma 2 by E. This we have already seen. So I expect you to revise. You might have revised and attending these classes. Without revision, these classes are of no use. Please understand that point carefully. Now, so let us try to calculate. Already the circumferential strain is given. 1 is circumferential. This is given as 7 into 10 raised to minus 4, if I am not wrong. This is equal to sigma 1 by E minus nu by E. I repeat, nu by E sigma 2. But what is sigma 2? It is sigma 1 by 2. No problem at all. So 7 into 10 raised to minus 4 is equal to, let me take sigma 1 by E common. So if sigma 1 by E is taken as common, so it will be 1 minus nu by 2. Okay. So 7 into 10 raised to minus 4 is equal to sigma 1 by, already E is given. I think it is 200 gigapascal. I convert into megapascal. 1 minus, and the Poisson's ratio is given. How much is that? 0.25, if I am not wrong. Yes, it is 0.25 by 2. Okay, no problem at all. So I have already calculated and values are ready. Let me take these values without wasting time. Kitna raha hai, sir? Okay, so I think if you calculate, you get sigma 1. And please note on that sigma 1 will be in megapascal. Why? Because we have converted giga to mega. So if this is in megapascal, this will also be in megapascal. So if I calculate, I am getting sigma 1 as 160 megapascal. But please note on that he has not asked sigma 1. He has asked the pressure to which the cylinder is subjected to. And we know that sigma 1 is, that is circumferential stress is PD by 2T. Okay, sigma 1 already we have calculated 160. And please note on that if this is in megapascal, this will also be in megapascal, provided these two are in consistent units. If you keep diameter in mm, thickness should also be in mm. So P into the diameter is given as 4000, 4000, and the thickness, let me check, एक बार check करेंगे. Diameter is 4000 mm and the thickness is 20 mm. So it is 20 mm. So you will get this value of P as kitna aa raha hai sir? I think 40. So this is 40. So this will be 100. So I think you are getting this as 1.6 megapascal. This is the first question. So the answer to the first question is, I think he has asked in where is that? It is a fill in the blank question. Find the pressure in megapascal. It is fill in the blank question. So the answer is 1.6 megapascal. Now let's go to the second question. Read this question. This is a good question. Please read the question. Now, please underline this thin walled beam of constant thickness shown in the figure is subjected to a torque of 3.2 kilonewton meter. The torque is given as 3.2. Kilo means 10 power 3 Newton meter. Meter can be written as 10 power 3 mm. So therefore, the torque is given by 3.2 into 10 power 6 Newton mm. Okay, no problem. And any other data given? Okay. And the shear modulus is given as 25. The shear modulus is given as 25 gigapascal. Let me write gigapascal as 10 power 3 megapascal. Okay. The angle of twist per unit length. He is asking what is the twist per unit length. Look at the unit. Again, it is a fill in the blank question. So it is radian per meter. Radian per meter. Rounded off to 3 decimals. Okay. This is the section given. So let me see. Okay. एक बार ले लेंगे हम. Actually, let me draw the figure 400, 100, 2. Okay. Actually, it is something like this. Let me show you very clearly. Yes. Now, look at. This is given as 400 mm. This is given as 100 mm. And the thickness is, let me check. ये thickness है कितना है सर? 400, 100 and 2 mm. Okay, the thickness is 2 mm. My dear students, please, and this is subjected to a torque. This is subjected to a torque. A thin vessel, a thin member subjected to a torque. Okay, no problem at all. Let's see how we calculate this. If it is a thin circular member, the polar moment of inertia, had it been something like this, the polar moment of inertia is 2 pi r cube t. If the thickness is t and if the mean radius is rm, okay, doesn't matter whether it is mean or inside or outside because the difference is so small. So generally we take mean. So therefore 2 pi r cube t. But it is thin. See the word clearly. It is thin. It is thin, but not circular. But not circular. And my dear students, if this dimension is taken as A and if this dimension is taken as B and if the thickness is T, we can calculate by using our mathematics the polar moment of inertia of thin rectangular section. The way we have calculated for the circular section, thin circular section, on similar grounds we can calculate for the thin rectangular section. And please, my dear students, you have to remember this, because in examination, if you start deriving, it will take a lot of time. I can derive, I have no problem, but please, I'm giving you a ready-made equation for the polar moment of inertia of thin rectangular section. देखो ये है thin. The polar moment of inertia is given by ABT by 3 into A plus B. The way we got the polar moment of inertia for circular section, so in welding we'll be seeing something like this. Similar to this, we have ABT by 3 into A plus B. Look at the unit. Aram se. AB are in mm. This is in mm. Mm cube into mm is mm power 4. Let me substitute. So A is 400. And please, my dear students, remember this equation. If you want, I can derive, but right now there is no need. ABT by 3 into A plus B. So therefore, A is 400, B is 100, thickness is 2 by 3 into A is 400, T is 100. So you will get the polar moment of inertia of this. And if I calculate, you are getting this as 13.33 into 10 power 6 mm power 4. So I have calculated this value. I think it is ready. 13 point, yes, exactly. So many millimeter power 4 is polar moment of inertia. Now what is he asking? Just check. We know that from our torsion, theory of torsion, T by J is equal to G theta by L. So he is asking theta by L. So what will be theta by L? T by GJ. Wait. We have already seen this in Newton mm. And this is Newton per mm square. And J is mm power 4. Let us check the unit. Mm square is gone. So Newton is gone. So this will be 1 by mm. Means theta is in radian and length is in mm. So you will get the answer in radian per mm. So theta is in radian and all length dimensions are taken in mm. So we will get the answer in radian per mm. But let's see whether he has asked in the same unit or not. We'll check, sir. Don't worry. So now, dekho, T is already known, 3.2 into 10 power 6. 10 power 3 is 10 power 6 Newton mm. So into 10 power 6 Newton mm by G. What is G? 25 into 10 power 3. 25 into 10 power 3 into J. What is J? Already we have calculated. J is 13.33, correct na? 13.33 into 10 power 6. It is 13.33 into 10 raised to 6. So he is asking twist per unit length. And if you calculate, you are getting this as 9.6 into 10 power minus 6 radian per mm. This is per mm. Because we have taken all length dimensions in mm, it is radian per mm. But let me check. No, he has asked in radian per meter. So this is not the correct answer. So therefore, 9.6 into 10 power minus 6 radian. Milli is 10 power minus 3 meter. So you take this to the top. So it will be 9.6 into 10 power minus 3 radian per meter is the right answer. 9.6 into 10 power minus 3. That is the right answer. So therefore the answer is 9.6 into 10 power minus 3 is the right answer. So there is a possibility of this question. Now we'll move to the next question. Take this question. Please read the question. Without wasting time, let's read this. Now, in a two-dimensional state of stress at a point, the maximum shear strain, it's not stress, is found to be 500 micrometer per meter. So gamma max, the maximum shear strain is given by 500 micrometer per meter. Okay, no problem at all. And the sum of normal stresses on two perpendicular planes is 40 megapascal. So sigma x plus sigma y, let sigma x and sigma y be the normal stresses on any two mutually perpendicular planes. So and that is given as how much, sirs? And 40 megapascal, and that is given as 40 megapascal. You know one golden point which I had discussed in my regular plus classes. What is that? The sum of the normal stresses on any two mutually perpendicular planes is independent of orientation, or it is independent of theta. It is constant. You take any two mutually perpendicular planes. On those two mutually perpendicular planes, the sum of normal stresses is always constant. So therefore, now can I say, my dear students, if sigma x, sigma y is 40, what will be the sum of normal stresses? Definitely it will be 40 only. Already we know this, no problem at all. And then the Young's modulus is 200 giga, already it has 10 power 3 megapascal, no issues at all. And giga is 10 power 3. Or Young's modulus is given E double times haga, sir, don't worry. So Young's modulus is 200 and the rigidity is 80 and the rigidity modulus is 80. Giga can be written as 10 power 3 megapascal. Okay, kahan gaya? And the Poisson's ratio is 0.25. The Poisson's ratio is 0.25. Any other data given? Poisson's ratio is 0. And the principal stresses, he is asking, what are the principal stresses? Have a look at this. In strength of materials in our regular classes, I have derived one equation. Gamma maximum by 2 is equal to epsilon 1 minus epsilon 2 by 2. Hope you remember this. Similar to sigma 1 minus sigma 2 by 2 is equal to tau max. Similarly, I explained in class, replace tau max with gamma by 2. Why gamma by 2? All this I had explained in my class in a neat manner. So therefore, gamma max can be written as epsilon 1 minus epsilon 2. This I have already given. Now, epsilon 1 is equal to sigma 1 by E minus nu sigma 2 by E. Similarly, epsilon 2 can be written as sigma 2 by E minus nu sigma 1 by E. So let me write gamma max is equal to epsilon 1. What is epsilon 1? Sigma 1 by E minus nu sigma 2 by E, okay, minus epsilon 2. What is epsilon 2? Minus epsilon 2. It is sigma 2 by E minus nu sigma 1 by E. Absolutely fine. So gamma max will be equal to epsilon 1 minus epsilon 2 by E. देखो एक बार, epsilon 1 minus epsilon 2 by E. Minus of minus is plus. So therefore it will be plus nu by E into sigma 1 minus sigma 2. एक बार चेक कर लेना, sigma 1 by E minus sigma 2 by E. Minus of minus plus nu sigma 1 by E minus nu sigma 2 by E minus nu sigma. I think it is correct. So therefore, gamma max can be written as, dear students, gamma max can be written as, what is that? Let me take sigma 1 minus sigma 2 by E common. So if I take sigma 1 minus sigma 2 by E common, it will be 1 plus nu. Let me check. If I take sigma 1 minus sigma 2 by E, it will be 1 plus nu. Absolutely correct. So therefore, gamma max is given as 500. 500. It is micro, means 10 power minus 6. So gamma max is 500 into 10 power minus 6. It is micro. So sigma 1 minus sigma 2 by E. Already E is given. How much is that? 200 into 10 power 3. It is 200 into 10 power 3 into 1 plus. Poisson's ratio is given as 0.25 if I am not wrong. Yes. So yahan se we can calculate the difference of principal stresses. How much is that? 500 into 10 power minus sigma minus 200 1 plus. Okay. So kitna aa raha hai, sir? The difference you are getting it as 80 if I am not wrong. And one more thing. If this is in megapascal, this will also be in megapascal, I think. And you know, there are two equations, two unknowns. He is asking the value of what? Values of principal stresses. Already you know, sum of normal stresses on any two mutually perpendicular planes is constant, whether it is normal stresses or principal normal stresses, they are absolutely same. Sum on two mutually perpendicular. So therefore, sigma x plus sigma y or sigma 1 plus, this is important thing which I had told you. So sigma 1 plus sigma 2 is 40. There are two equations and two unknowns. I can easily solve. Add this, I remove. 2 sigma 1 is equal to 120 and sigma 1 is equal to 60 megapascal. 60 megapascal. And what will be sigma 2? And sigma 2 will be equal to, kitna aa raha hai, sir? Sigma 1 is 60, sigma 2 is equal to minus 20 if I am not wrong. Minus 20, is it correct? Yeah, 60 and minus 20. 60, yes. So the answer is, where is that? 60 and minus 20. B is the right answer. B is the 60 and minus 20 is the right answer. Okay, chalo. Let's go to the next question. So let me take up one very good question, sir. Let me take up one very good question. Where is that? Where is that? Aram se sab karenge, sir. Don't worry. Ha. This is the question. which is very, very important and very, very important. Take this question. Dear students, take this question. The components of stress in a body under plane stress condition in the absence of body force. Body force means what? Weight. There are no body forces. In the absence, he said, there are no body force or weight forces. Okay, chalo. Now, is given by, please note down that stress is not constant. It is varying in the x direction. It is varying in the y direction. And what does sigma xy mean? Sigma xy is nothing but tau xy, and that is given as tau x 12xy. But and the coefficient a, he is asking the value of a. Dear students, he is asking value of a for equilibrium. For equilibrium, this is a very a such that the equilibrium body is in equilibrium. It is a very, very good question, sirs. So please let me derive certain things, and finally after the derivation I'll ask you to remember one equation. First I'll derive. Okay, now it is not a constant stress, it is a variable stress. Okay, now observe here. Let me derive everything clearly. Now say this is the origin, and this is x direction, this is y direction. Let me take this length as dx. I am taking a small element, and let me take this length as dy. Let this be dy. Okay, no problem at all. Now thoda isko erase karenge sirs, so that I'll have some place to work on. Yeah. Let this be dy. Now, imagine the stress to be sigma x here. But please note down that this stress is a function of x. X is varying in this direction. So please note down that if it is sigma x here, it's not sigma x here. It is a variable stress. It is a variable stress. So be careful. In mathematics, we have studied Taylor's expansion principle. What is that? Taylor's expansion rule. So what is that? So if there is any property here P, at a distance dx, it will be simple mathematics. So it will be P plus dou P by dou x dx. Similarly, if there is any property Q here, at a distance dy, it will be Q plus dou Q by dou y dy. It is simple mathematics, dear students. It is simple mathematics. This is from Taylor's expansion series after neglecting higher order terms, because the del Q is very small, del y is very small. The higher order terms square will be much more smaller. Therefore, we can neglect. This is simple mathematics. This is simple mathematics. So don't worry about that. So don't worry. So this is simple mathematics, and try to understand. So let me, now what I do is, अगर यहाँ पे सिग्मा x है तो at a distance dx it will be sigma x plus dou, let me erase this sirs, that's why I thought initially itself, ये भी बस नहीं हो रहा, कोई बात नहीं, no problem. Sigma x plus dou sigma x by dou x into dx, absolutely fine. Similarly, origin say, yeah, if it is sigma y, what will be the stress here? It will be, because why are you not taking sigma x means sigma x here? He gave it as a special case of variable. Had it not been variable, I would have directly taken it as sigma x only. Arey yaar, please understand carefully. In this case, the stresses are varying with x. So if they do not vary, I will take directly sigma x, sigma y, sigma y. But they are given as a function of x. It is a special problem. So if it is sigma y, it will be sigma y plus dou sigma y by dou y dy. Absolutely fine. If it is sigma y, it will be dou sigma y by dou y dy. Very good, sir. Now, similarly, let the shear stress here be tau xy. And we have already seen, if it is tau xy, here also it will be tau xy. Here also it will be tau xy. Absolutely fine. Now, if it is tau xy, what will be the shear stress here? What will be the shear stress? Agar tau xy hai, at a distance dx, it will be, this can be written as tau xy plus dou tau xy. ये कितना distance है sir? On this it is tau xy. So at a distance dx it will be by dou x dx. Similarly, if it is tau xy here, at a distance dy, it will be tau xy plus dou tau x by dou y dy. Let me draw clearly. You don't have any confusion. Let me draw clearly, sirs. Let me draw very clearly. If it is sigma x at a distance dx, this is dx, it will be sigma x plus dou sigma x by dou x dx. Similarly, if it is sigma y, this is dy. So at a distance dy, it will be sigma y plus dou sigma y by dou y dy. Similarly, if it is tau xy, at a distance dx, it will be, हाँ अगर ये डाउन है तो अपवर्ड है शेयर. If it is tau xy, it will be tau xy plus dou tau xy by dou x. Listen, this is x at a distance, this is here at a distance x, it will be into dx. Very good. And anti-clockwise तो clockwise, so ये anti-clockwise है. अगर ये anti-clockwise है तो ये clockwise. देखो देखो एक very important, if this is anti-clockwise, this has to be clockwise. I repeat, अगर ये anti-clockwise है तो ये complementary clockwise होना चाहिए. So if this is anti-clockwise, देखो down up anti-clockwise, this has to be clockwise. Correct ना? This has to be clockwise. Wonderful sirs. So if this is anti-clockwise, this will be clockwise. So देखो अगर यहाँ पे tau xy है तो and you know very well at a distance dy क्या होगा? At a distance dy, this will be, so यहाँ पे place नहीं है तो this can be written as tau xy plus dou tau xy by dou y dy. Okay, these are the stresses. But clearly he said it is in equilibrium. Please understand, sirs, it is a special problem. Finally, even though I am going to derive, finally I ask you to remember the equation so that you can save time in examination. It is in equilibrium. Let us take perpendicular to the screen, plane of the screen, let the width be 1. So now sum of the rightward forces should be equal to sum of the leftward. So let us take horizontal equilibrium. I mean equilibrium in x direction. So what will be this? Sigma x, dear students, sigma x plus dou sigma x by dou x dx. And this is the stress. What will be the force? Equilibrium is for forces. So what will be the force? And this length is dy and width is 1. It's something like this. This is dy and the width is 1. Width is 1. On this it is acting. So what is the area? So it is a dy. It is dy into 1. So it will be dy. It is the rightward force. And there is one more rightward. Total rightward should be equal to total leftward. This is rightward. This is rightward. And please note down that the width is given as 1. The width is taken as 1. So this shear is acting. What is this length? Dx. So this stress into area. What is that area? Dx into width is 1. So you multiply this with dx into 1. So plus. Why plus? Because this is in the rightward direction. This is rightward. This is also in the rightward. So therefore tau xy plus dou tau xy by dou y dy into dx into 1 into dx into 1. So why? Because this length is dx, this length is dx, this is 1. So dx into 1. So total rightward, total leftward. And what is leftward? Minus likho. Yeah. So this tau xy is acting on dx, width is 1. So minus tau xy dx. Yes sir. Tau. और ये leftward, ये भी leftward है तो this is acting on this dy into 1 so it's sigma x minus y minus because left minus right plus and that is equal to sigma x into dy into 1. This is dy into 1 is 1 and that should be equal to 0. Why 0? Because he said it is in equilibrium. Now have a look at this. Sigma x into dy, sigma x dy, so this is cancelled. Tau xy dx, it is cancelled. So what is left? Dou sigma x by dou x dx dy plus dou tau xy by dou y into dx dy and that should be equal to what? 0. Take dou x dx dy common. So you will get dou sigma x by dou x plus dou tau x by dou y is equal to 0. I have taken these two common, dx dy common. So you are left with dou sigma x by dou x plus dou tau y by dou y is equal to 0. Great. Similarly, if I take equilibrium in y direction, what do I get? This is in the x direction. And if I take in y direction, I get dou, sum of the upward is equal to sum of the downward. So you will get this. Yes. This is in the y direction. I have not taken, but I have just shown. Now apply this. So from examination point of view, Please, I request you to remember this, because already I have derived. It is in equilibrium. Already have derived. Just remember this. Just remember this. That is enough. Dou sigma x by dou x plus dou tau x by dou y is equal to 0. It is in x direction. So let us put it here. देखो एक बार देखो क्या था इक्वेशन सर. Dou sigma x by dou x plus dou tau xy by dou y is equal to 0. Let me check. Is it correct? Is it correct? Dou sigma x by dou x, dou tau x. Yes, yes, yes. Now, देखो, sigma x is given as ax square in the problem, ax square, and tau xy is given as 12xy. So, what is dou sigma x by dou x? Dou sigma x by dou x is x square. Differentiate with respect to x. तो ax square क्या होगा? 2ax plus dou tau by dou y, dou tau by dou y. So whenever you are differentiating partially, other variable is treated as constant. You are differentiating with y, so x will be constant. So what is dou tau x by dou y? Dou tau x by dou y will be equal to 12x. So this is 12x, and that should be 0. So I think 2x can be removed. 2x is common, so a plus 6 is equal to 0, so you get a as minus 6. This is very important question, sirs, and he is asking quotient a, the coefficient a, and it is a fill in the blank question, so it is minus 6. Let me check whether it is right or not. It is minus 6, sirs. Yeah, it is minus 6. Similarly, let's see in y direction. अगर हम y direction में equilibrium लिए, तो what will be that? Dou sigma y by dou y plus dou tau xy by dou x should be 0. चेक करते हैं. डो सिग्मा बाई डो वाई, डो सिग्मा बाई डो वाई, तो क्या आ रहा है सर? डो सिग्मा इट इज पार्शियली विथ वाई, तो एक्स विल बी 0. डो वाई डिफरेंशिएट विथ रिस्पेक्ट टू वाई, तो माइनस 12 वाई, तो दिस इज माइनस 12. अरे यार माइनस 6 वाई स्क्वायर इज 2 वाई, 2 into 6 is 12, minus 12 वाई प्लस डो टाउ बाई डो एक्स. दिस सिग्मा एक्स वाई मीन्स टू एक्स वाई, डो टाउ बाई डो एक्स. अगर डो टाउ बाई डो एक्स ले रहा है तो डिफरेंशिएशन विद रिस्पेक्ट टू 12 आ रहा है. यस, इट इज सेटिस्फाइड. Yes, it is satisfied. He may be asking you in examination which equilibrium is not satisfied, something like this. So that such questions can also come. Yes, the vertical equilibrium is satisfied, and if you want horizontal equilibrium to be satisfied, and if you want incomplete equilibrium, obviously our a value should be equal to minus 6. It is a very, very good question. Okay, chalo, let's proceed. Wonderful question, sirs. आराम से, कोई टेंशन नहीं है सर. Let's try to do as many questions as possible. ये क्या है सर? A simple question. So we'll do combination of tough and easy questions, so that we'll be in a comfortable zone. A component is made of metal with modulus of elasticity which is 200 megapascal, okay, and the rigidity modulus is 80 megapascal. I think the values are not correct. I think it should be giga, but he has given mega. चलो कोई बात नहीं, but it should be giga. It should be giga. It should be giga. Okay, कोई बात नहीं. And it experience. Let us take concept. It should be giga. Okay. Now it experiences an axial strain of. Axial means let us take x direction. Let us take axial in x direction and lateral in y direction. Okay, so the axial strain is 1000. What is the lateral strain? Very good. If you want lateral strain, just to find out Poisson's ratio, because Poisson's ratio is lateral strain by longitudinal strain. So the longitudinal or axial strain is given as 1000. This is 1000. If you can find Poisson's ratio, I can easily find the lateral strain. There is nothing in this problem, and there is a relationship between E and G. E is equal to 2G into 1 plus nu, if I am not wrong. So 200 is equal to G is luckily both are in the same unit, so no problem. So 80 into 1 plus G. तो बताओ सर क्या वैल्यू आ रहा है? 200 into 80 into 180. Okay, I think we can calculate nu, and it is turning out to be 0.25. So this is 0.25 by lateral strain by longitudinal strain. And what is the strain in x direction longitudinal? It is 1000. So therefore it is 250. So answer aa raha hai 250. Is it okay? This is 250. It's a simple question. Let's take other question. Aram se. Ha, ye wala. Let's take this question. Please read this question. A load P is applied to the free end of a stepped cantilever beam as shown. So it is a stepped cantilever. This is the fixed end and this is the free end, but please note down that it is not prismatic. So the cross section is varying along the length. Okay, now the moment of inertia of this portion for the first 2 meter is I, and for the later portion is 3I, no problem at all, respectively. Ignoring the transverse shear and stress concentration, whenever there is a change in cross section, there are stress concentration effects, but he said neglect stress concentration effects. And what is the deflection at a point where the load is applied? So the load is applied here, and that load is 3 Newton P, and he is asking what is the deflection under the load P? Koi baat nahi, sirs. So let me try to do, whenever the load is given and he's asking deflection under the load, it will be easy for me to use a strain energy method, because my Castigliano, one of the Castigliano's theorems, it say ki the partial derivative of the strain energy with respect to load, point load, will give deflection under the load. Already there is a load. So if I differentiate, calculate strain energy and differentiate with respect to this load, it will give me directly deflection. So I will try to utilize my strain energy. But यहाँ पे देखो सर, आराम से, कोई टेंशन नहीं. एक काम करते हैं सर, let me erase this. No. Let me change the color. I think देखो. Let us take. I think this color is okay. दिख रहा है? Okay, ना. इस ग्रीन ओके, चलो ओके, देखते हैं. नो 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 नो. Yeah, let us take this length as x. Let this section be xx. Let this section be xx. Can you tell me what is the moment at xx? What is the moment at xx? If you want moment, bending moment, it is p into x. Now observe here. Is there any load from this end to this end apart from p? No. There is only one load, that is p, throughout this length. Okay, no problem. So that's why the same bending moment can be equation can be extended throughout the length, because it's only, this is not, in this there is no moment of inertia, it is simply a moment. Moment is what? Force into perpendicular distance. So there is a force, there is a perpendicular distance. So therefore the same bending moment equation can be extended throughout the length. So therefore I can use this equation throughout the length of the beam. So there is no problem at all. And you might have studied the strain energy due to bending. I have already derived these equations. Due to bending, the strain energy is given by m square L by 2EI, where m is the bending moment throughout the length L, but here the bending moment is not constant throughout the length. So that's why what I do is, look at, I will take a small length dx. Listen carefully. So my dear students, this bending moment is varying with x. So at this section, the bending moment is px, p into x. So in the small length dx, x variation is very small, so bending moment variation is very small. So in a small length dx, I can assume the bending moment to be constant. So in that small length, let us calculate strain energy. And if I want the total strain energy, I'll integrate. Okay, right. Now, let's see how we proceed, dear students. आराम से, कोई टेंशन नहीं है सर. इधर देखो. Now, the bending moment is given by px. So m square L dx by 2EI. That is the strain energy in a small length dx. I repeat, sirs. So in the small length dx, the strain energy is given by m square. M square is px square L. The length is dx. The length is dx by 2EI. But यहाँ पे एक problem है, sirs. I is not same throughout because it is not prismatic. I is not same. So what am I supposed to do? एक second रुको, sirs. इधर देखो. What I do is, I will integrate from x is taken from this left end, so free end. I will integrate from x0 to x2 by using I, by using I, and then if I want to integrate from 2 to 3, please observe, here x is 0 and here x is 2. So throughout this length, the moment of inertia is constant. But यहाँ पे, what is the value of x? X is increasing. So for this section, x is 2 and this end x is 2 plus 1. This is 2 plus 1, 3. So for this, the limits are 2 to 3. For this, limits are 0 to 2. So therefore, what we do is, dear students, I will integrate, the moment of inertia is I. It is from 0 to 2 plus m square, same bending moment equation, m square L by 2EI. So what is I? This I is 3I. And my limits are x is 2 to 3. Observe clearly. So that will give me total strain energy. That will give me total strain energy. Observe clearly. So I have written the equation. So m square L by 2a from 0 to 2 and from 2 to 3. So 2 to 3. So x is 2 and 2 plus 1 3. ये हो गया. अब देखो. Now let me integrate. So therefore total strain energy p square, p into p is p square by 2ei. What is x square dx? X square dx is x cube by 3 and 0 to 2 plus p square by 2 into 3 is 6ei. And what is x square dx? Let me repeat. 2 into 3 is 6ei. So x square dx is x cube by 3. My limits are 2 to 3. No problem at all. So total strain energy is p square by, what I do is 3 into 2 is 6. 3 into 2 is 6. So 6ei, I will take it out. Let me repeat. P square, 3 into 2, 6 eia. And what is 2 cube? 2 cube, upper limit is 2. 2 cube is 8 minus lower limit is 0. Already 3 is taken out. 3 into 2, already 3 is taken out. Plus p square by 6ei. No problem. There is 3 here. Upper limit is 2 cube is 27 minus lower upper limit is 3 cube is 27, 3 cube, lower limit is 2, 2 cube is 8. So therefore the total strain energy is given by p square by 6ei, p square by 6ei, 8 plus 27 minus 8, kitna aayega sir? 19, I think it is 19 na. Is it correct? Absolutely correct. So therefore the total strain energy is given by p square by 6ei into 24. तो कितना आ रहा है सर ये? 24 plus 19 is 43 by 3. Absolutely fine. So now I want deflection under the load. So if you want deflection under the load, my Castigliano's theorem says, देखो एक बार, the total strain energy is given by, what is the total strain energy? 43p square, 43p square, okay, 43p square by 18ei, 18ei by 18ei. So therefore deflection will be equal to, according to Castigliano's theorem, differentiate partially total strain energy with respect to load. Wherever you want deflection, there has to be a point load, and you have to differentiate with respect to point load. That is Castigliano's theorem. Okay, so now delta deflection is, now differentiate this 43 by 18ei. And what is the differentiation of p square? It is 2p. So therefore 2 1s, 2 9s. So therefore it will be 43p by 9ei. But already p value is given as 3. Already p value is given as 3, my dear students. Substitute p. So delta is equal to 43. Already p is given as 3 by 9ei. So this 3 is gone. So you are left with 43 by 3ei is the deflection under the load. 43 by 3ei. Let me check. Is that option there? 43 by 3ei. Yes, it is there. Yes, it is there. Absolutely no problem at all. Wonderful question, sir. Wonderful question. कोई problem नहीं है. वाह. आराम से. Take this question. Let us do tough, easy. Smoothly will proceed without any problem. The value of Poisson's ratio at which the shear modulus is equal to bulk modulus. So when the shear and bulk modulus of an isotropic material is same, what is the value of Poisson's ratio? Okay, we know that E is equal to 2g into 1 plus nu. We also know E is equal to 3k into 1 minus 2 nu, where nu is Poisson's ratio, E is Young's modulus, G is rigidity modulus, and K is bulk modulus. Okay, this first equation is giving me Young's modulus, second equation is giving me Young's modulus. So Young's modulus E, to equate these two, because both are giving me E. So 2g into 1 plus nu is equal to 3k into 1 minus 2 nu. Absolutely fine. But he said G is equal to K. When G and K are same, under that condition, what is the value of nu? So therefore, G and K are same. So hata dena. 2 into 1 is 2, plus 2 into nu is 2 nu is equal to 3 into 1 is 3, minus 3 into 2 is 6 nu. Okay. So bring 6 to this side, minus 6 to this side. So already there is 2 nu, minus 6, 8 nu is equal to, you take 2 to that side, so 3 minus 2, this is 1. So 8 nu is equal to 1, or nu is equal to 1 by 8. So where is option? I think it is D. It's D, my dear students. It's D. Okay, so we'll take up our remaining questions neatly in our next class, so no problem at all. Happily we'll try to cover all these questions. Beautiful questions are given, so we'll see in the next class. Thank you, my dear students. God bless you all.